Unbalanced forces is forces on an object that cause the net force to be other than zero. Unbalanced forces produce a change in motion or acceleration. Tug-of-war demonstrates unbalanced forces because the side with two people is applying more force than the side with one person to create an unbalanced force.
Balanced forces are forces on an object that cause the net force to be zero. Balanced forces do not cause a change in motion or acceleration. Tug-of-war also demonstrates a balanced force because with two forces on each side, the net force is equal to zero, which makes a balanced force.
Air resistance is the opposition of the atmosphere to forward movement, also called aerodynamic drag. Dropping the paper with the box and ball shows that the object's mass and shape depends on how quick the object reaches the ground due to air resistance.
Gravity is a force of attraction between objects that is due to their masses. When Lily dropped to the ground, gravity helped force her down, pulling her downwards.
Conservation of momentum is a principle stating that the total linear momentum of an isolated system remains constant regardless of changes within the system. Playing pool shows conservation of momentum because when the cue ball hits the other ball, it transfers its momentum to the other.
Projectile motion is the curved path an object follows when thrown or propelled near the surface of the earth. Throwing a ball shows projectile motion because you are using both horizontal and vertical motion in the process of the ball being thrown between two people.
Newton's first law of motion states that an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted on by an unbalanced force. The penny drop shows Newton's first law of motion because the penny remained at rest until the note card was pulled out from under it, posing as the unbalanced force.
Newton's second law of motion states the acceleration of an object depends on the mass of the object and the amount of force applied. When Sydney was being pushed lighter, the less higher she went, due to the force applied. When Maddie applied a greater force, Sydney was able to swing higher, relating to Newton's second law because the greater force applied, the greater the acceleration.
Newton's third law of motion states whenever one object exerts a force on the second object exerts an equal and opposite force on the first. Jumping on a trampoline is an example of Newton's third law of motion because when you jump down, the trampoline uses your momentum to propel you upwards.
Fluid friction opposes the motion of objects traveling through a fluid. Playing tennis shows that fluid friction acts on the ball going through the air because the friction is slowing the ball down.
Inertia is the tendency of all objects to resist any change in motion. When the car slammed on the brakes, the passengers were forced forwards because their bodies resisted to change motion in a matter of seconds.
Acceleration is the rate at which velocity changes. An object accelerates if its speed changes, if its direction changes, or both the speed and direction change. Riding a bike is an example of acceleration because Lily's direction was continually changing while riding in a circle.